So today I want to walk you through AISA, which is an Agentic AI Systems framework. So it is not a library or a specific implementation. It is a reference framework, a way of thinking clearly about how Agentic AI systems are structured and how their components interact and where responsibility should live. So, as agentic AI systems grow more autonomous, the biggest challenge is no longer how smart the model is, but it's how reliable and controllable the overall system becomes. So, ISA was created to address exactly that problem. So, what you are seeing here actually is a layered view of ISA. I will explain layer by layer, starting from the bottom and moving upward because that mirrors how agentic system actually operates. So starting from LLM foundation layer, which is a base of the framework, and this is where language model lives. Okay, so more important, not just the model itself. So this layer includes prompting, context management, structured output, safety grounding, and resource constraints like tokens and latency. So a key idea here is that the model should be treated as a constrained reasoning component, not an autonomous decision maker. So the foundation layers defines how the model is allowed to reason, what format its output must take, and what constraint it must respect. And many failures in agentic systems starts here, from hallucinations, prompt conflicts, insufficient grounding. So this layer must be explicit and controlled. Now, moving to a tool and environment layer, which is the interface of external actions. And here, the agent does things. So this layer defines the execution boundary between the agent and outside world, and any interaction with APIs, databases, file systems, or code executions happens here. So this is the critical idea here is that reasoning and execution are separate concerns. So the model can propose an action, but it does not execute it directly. So the tool layer validates schemas, enforces permissions, applies the sandboxing, and ensures safe execution. So this separation is essential for security and auditability. So especially as agents gain the ability to take real world actions, let's say. Then we move to what I call it a goal directed behavior, which is the conjunctive agents layer. And if you notice, we are discussing many things related to task decomposition, planning, memory usage, reflection, and termination decisions, which all happen here. So the conjunctive layer decides what to do next and how to execute it. So it reasons over goals, context, and prior outcomes and produce structured action proposal rather than raw instructions. So this is actually very important because isolating conjunction in this layer let us analyze reasoning behavior in a dependent way, right? From execution mechanism, and this is very crucial for debugging and evaluation. Now we're moving to discussing about multi-agent and workflow orchestration, which is lies in agentic infrastructure layer. And this layer is responsible for coordination. So it manages state propagation, multi-step workflow flows, concurrency, retrials, and observability. So in practice, this is where long horizon behavior becomes manageable. This infrastructure layer ensures that the agent runs in a traceable, reproducible, and bounded. So it prevents runaway loops or invisible failures. And this is, of course, very important, especially when discussing multi-agent systems. So this layer allows handling the coordination, the delegation, and the shared states. After these main components in the agentic AI system, we move to evaluation and feedback layer, which is a really very important step Because as you know, traditional AI evaluation focus on static accuracy, right? But agentic systems requires like something different. We call it trajectory level evaluation. And this layers monitors behavior across entire agent runs, including tool use, state transitions, and termination quality. So in short, it enables detection of failures that only emerge over time. So this layer evaluation is not afterthoughts, no. In AISA, the evaluation is a first-class architectural layer, which is continuously feeding back into system improvements. Okay, this is was the evaluation feedback layer. Then I thought maybe we it is very important to include some topics related to development and deployment layer because as agentic system evolve rapidly, prompts change, tool change, and workflows also change. So this layer ensures that such changes are version tested and of course reproducible. So this layer, in short, support controlled releases, regression testing, and rollback. So it's treating agentic systems as living software systems, not static models. Lastly, we have at the top the governance, ethics, and policy layer. And this is very important because here we define the system-wide constraints like permissions, safety rules, accountability, auditability, and of course human oversight. And rather than being enforced and ad hoc, no, governance in AISA is propagated downward through policies that shape reasoning, execution, evaluation, and deployment. So this is allows agentic systems to scale responsibly without relying on informal guidelines or manual oversight. So this is the overall layers. And the key idea behind AISA is simple but powerful. Agentic AI is a systems problem, not a model problem. So by separating concerns and making responsibilities explicit, AISA helps us reason about agent behavior, diagnose failures, and design systems that scale in a capability without scaling risk. So you don't need to adopt AISA to benefit from it. Even using it as a mental model that can improve how you design, evaluate, and discuss agentic AI systems. Thanks for watching, and I hope this framework helps you think more clearly about the next generation of agentic AI.